introduction and explanation of three fault types on underground cables, the difficulties to locate the exact location of faults, and next the popular method, which is the Varley loop test, and the other method, search pulse reflection, and lastly the next for the introduction of underground cables for distribution system. The underground cables play a crucial role in the distribution of electricity, providing a hidden and reliable solution for power transmission. So these underground cables are placed beneath the ground surface, which provides some level of protection and designed to carry electrical current from power sources to various points of consumption. However, faults can still occur in underground cables, and locating the exact location of these faults can be challenging. So the purpose of this task or this assignment is to explain the fault types or on underground cable, the difficulty to locate the exact location of faults, and the popular method and the other method, which is the Varley loop test and the search pulse reflection. Let's move to the three fault types on underground cables. The first one is open circuit faults. The open circuit faults occurs when one or more cables conductors break. It leads to discontinuity. This discontinuity also occurs when the cable comes out of its joints due to mechanical stress and result in a complete loss of power. So the faults can be detected by using the megger, and the megger will read if you need when connected between the conductor and the earth. Next, the short circuit faults. The short circuit faults occurs only in multi-cord cable, which is two or more conductors of the same cable come in contact with each other. So this creates a bypass for the electrical current, leading to a surge in current flow. And it occurs when the individual insulation of the cable is damaged and result in circuit breaker stripping. So the megger will read 0, which indicates the short circuit faults. Next, for the earth faults, the earth faults occurs when any of the conductors of the cable comes in contact with the earth. So this usually happens when the outer sheets is damaged due to chemical reaction with the soil. The current will take the least resistive parts and flows through the earth. So the megger will show nearly 0 reading, which indicates to the earth faults. Let's go to the difficulties to locate faults. The first one is accessibility issues. Since the cables are laid under the surface and making the visual methods of inspection do not work effectively. So an excavation process is required to locate the damage that accesses and exposes the cable. This leads to time-consuming, labor-intensive, and disruptive to the surrounding area. So for the environmental factors, the factors such as soil conditions and moisture levels can impact the accuracy of faults location techniques. So the moisture in the soil can impact electrical conductivity and signal propagation, which makes it more difficult to locate faults precisely. And the last one is specialized technique and the needs of specialized techniques and equipment. So locating faults in underground cables requires the use of specialized techniques and equipment. So the Varley loop method and search pulse reflection, this is the example, maybe necessary for accurate fault location, and the expertise to interpret the data of this method may present a challenge in fault location efforts.
Varley loop test method. Varley loop test method is a technique to determine insulation resistance of cable or electric equipment. It is a loop test for finding location of fault in underground cable. It is used to locate the earth fault and also the short circuit fault using a Wheatstone bridge principle. It involves a series of resistors connected in a loop with 2 points of the loop connected to the conductor of the cable or equipment that being checked. Using the Ohm's law, the insulation resistance may be estimated by measuring the voltage drop across each resistor in loops. So, Varley loop test is widely used in electrical industry to evaluate the insulation uh, of the cable and equipment, as it is simple and reliable method for discovering defect or weakness in insulation cable. So there are two types of loop and connection in Varley loop test, which is one to check the ground or earth fault, and the second one is to check the short circuit fault. So in the Varley loop test loop and connection, there are two types of cable used, which is the sound cable and also the faulty cable. So sound cable is a section of cable that is free from fault and it is used as a reference. And the faulty cable is a section of cable that contains the fault that we want to test. So sound and faulty cable is connected in a series with a test loop, including a battery and also the fixed resistor. So the loop will be used to create the voltage drop across the sound and faulty cable. Thus, we can calculate the resistance of faulty cable. Operating principle of Varley loop test. So just now, I said that we use a Wheatstone bridge principle. So for the example, for earth fall, so R3 in the diagram is a resistance of the cable and the RA is the variable resistor. So first, the switch S is connected to the position 1. The variable resistance R is varied till the bridge is balanced, which means that the galvanometer gives zero deflection. And then let the variable resistance is balanced for the value R equal to RA. So when we get the balance equation, then the equation will be R1 over R2 is equal to R3 plus Rx over the RA. And then we want to get the R3 plus Rx as the subject, arrange it, and we will get R3 plus Rx is equal to R1 over R2 time with the RA. Where the R3 plus Rx is the total resistance of the loop and it is assumed to be known, which means have a value. After that, switch S is connect to the position 2. So the variable resistance R is varied till the bridge is balanced. Let the variable resistance is balanced for the value R is equal to RB. For just now, for the position 1, we assume the R is equal to RA. And now for the position 2, we assume that R is equal to RA, so RB. So the equation that we will get is the R1 over R2 equal to R3 over Rx plus RB. So now we want to calculate the Rx plus RB. For just now, we want to know the value for R3 plus Rx, which is the total resistance of the loop. So to get the value for Rx, we need to make the Rx plus RB as a subject. So to get the Rx plus RB, to get the value of Rx just now, we need to make the Rx plus RB on the numerator. So we will add the 1 at both sides. So we will get the equation of R1 plus R2 over R2 is equal to R3 plus Rx plus RV over with Rx plus RB. So now we just want to have the value for Rx. So we will arrange it until will get the Rx is equal to R3 plus Rx time with R2 minus with R1 RB divide by R1 plus R2. Advantages and disadvantages of Varley test loop. For the advantages, first, Varley test loop is a simple and reliable method for measuring insulation resistance of a cable or electric equipment because it doesn't require any specialized equipment or highly skilled technician. Secondly, it is non-destructive method because it doesn't damage cable that want to be tested. It is important when testing underground cable as it can be difficult and expensive to access and repair the damaged cable. Thirdly, Varley test loop provide an accurate measurement of fault location in cable because it can minimize amount of digging out the ground which the excavating to repair fault as the exact location has been known. Next, the disadvantage of Farley test loop. Farley test loop not suitable for measuring resistance in circuit with high inductance and capacitance. Secondly, Vary test loop require a relatively large number of resistors, which can be expensive and difficult to obtain. And lastly, a vary test loop has a limited range and may not be suitable for testing cable over long distance, as it relies on the use of relatively low voltage.
Another method for locating the location of fault in the underground cable is surge pulse reflection method. This method relies on injecting a high-energy surge pulse into the cable and analyzing the pulse reflections when it encounters the fault to determine the location. This method is commonly used in power distribution systems with larger and long-run power cables. It is effective in detecting faults such as open circuit, short circuit, and earth faults. The first component in the surge pulse reflection connection is an impulse generator. It is a specialized device used to generate high-energy surge pulses. It is directly connected to the cable without a filter, which can limit both the voltage and current applied to the fault. Second component is the storage oscilloscope, also known as analyzer, used to receive and analyze the reflected pulses that occur when the surge pulse encounters a fault. Another one is current coupler. It is used to safely couple the surge pulse from the thumper into the underground cable to ensure that the surge pulse is injected into the cable without causing any damage to the equipment and also the cable. Also to avoid danger towards the technicians working when locating the fault. Okay, now moving on to the operating principle of surge pulse reflection to understand how it works. Firstly, the impulse generator injects a high-energy surge pulse into the cable. The pulse will first pass the fault and it will reflect off of the end of the cable back toward the fault. The inrush current causes the fault to establish a low resistance arc and generates a new wavefront. This new wavefront travels back toward the impulse generator where it will reflect back from the generator toward the fault due to the short circuit of the capacitors in the generator. The fault also appears as a short circuit, which makes the wavefront reflect back and forth between the fault and the generator until its energy is depleted. So these back and forth reflections of the pulse between the fault and the impulse generator will result in current and voltage transients, where an inductive pickup will display on the storage oscilloscope. The oscilloscope will then measure and analyze the time delay between the injected pulse and the reflections, which will determine the distance to the fault location. Now we look at the advantages and disadvantages of the surge pulse reflection method. Advantage. Because the surge pulse is injected with a high energy, it will allow for a better penetration into the cable, which means that we can better detect the location of faults. This just also means that it is more accurate at locating the fault, and this method can even provide the information about the depth of the fault. This method is also time-saving since it eliminates the need for guessing or manual tracing of the underground cables to locate the fault, which can be very time-consuming and even hazardous. Next is disadvantage. The injection of a high-energy surge pulse can damage the cable, which can be even more hard and expensive to fix. The work for interpretation of the pulse reflections also requires more skill and experience compared to other methods. Lastly, this method requires a specialized equipment capable of generating and measuring a high-energy pulses, which is very costly and may not be readily available for small-scale maintenance operations. In conclusion, the underground cable faults can be located using numerous methods, among which are the value loop test and the surge pulse reflection. The value loop test method is used to determine the insulation resistance of the cable or equipment and involves loop tests using resistors. This method is very simple and reliable in providing an accurate location of the fault. On the other hand, the surge pulse reflection relies on injecting high-energy surge impulse into the cable and analyzing the reflections to determine the fault location. Due to the better penetration from the high-energy impulses into the cable, this method provides even better detection of the fault location.